I am Upasana Dugal, Assistant Professor, Department of Computer Science and Engineering, Babu Banarsi Das University, Lucknow. Today I am give you the brief idea about the automata theory. In this course, we are going to mathematically model a computer or a machine in general, and then we are going to study the theory about it. See, the word automata computation. The word computation means any task performed by a calculator or a computer. So, in this course, I have discussed, we are going to study the theory about the machine. That means what? We are going to mention the capabilities of the machine, what are the problems that could solve by this machine, and what are limitation of such a machine. So the term automation or automata is derived from the Greek word which means self-acting. Automata means self-acting. An automation is an abstract self-propelled computing device which follows a predetermined sequence of operations automatically, as I have mentioned in the slide also. So now the first concept of automata theory is given by Alan Turing. He is also known as the father of modern computer science. He was an English mathematician which gave the idea of Turing machine. Next, this is the history of theory of computation. First, in 1930s, Alan Turing studied Turing machine, decidability and halting problem. Then in late 1940s to 1950, the concept of finite automata came into existence, and the Chomsky proposed the Chomsky hierarchy for formal languages. Then in 1969, in the field of theory of computation, introduced intraceable problems like NP-hard. And in 1970, this modern computer science compiler computational and complexity theory evolved. Next, this is the two definitions I am going to discuss, the language and grammar. Before this, we are going to discuss the hierarchy of automata. Like as we have studied English grammar in our childhood, first we studied what alphabets, and after that from the help of alphabets we learned the word, and from words we used to learn sentences, and then we were able to create the paragraph, or we can say a letter. In the same manner, in automata theory, first of all there is an alphabet. Alphabet is what? It is a finite collection of symbols. Symbols include binary number, as discussed in the slide also, 0 and 1, the lowercase letters from A to Z, alphanumeric or DNA molecule letters like A, C, G, T. After alphabets, we come to the existence of string. String is a finite, or we can say finite sequence of symbols from the alphabet, from the given alphabet. Like we are this epsilon is a null string, empty string. It is a string which contains no alphabets. So the length of the epsilon string is 0. This epsilon string means the number of symbols used in the string. Like I have given here the example x is equals to 0, 1, 0, 1, 0, 0. How many input symbols are here? These are 6 symbols. So the length of x is 6. Now this string is I have taken this string from the given alphabet 0, 1. Now, the power of an alphabet. The power of an alphabet includes this summation symbol. I have already told you it represents the alphabet. So, the power of alphabet means it is a union of the string having length 0, of having length 1, or having length 2, and so on. This epsilon asterisk is also called as Kleene closure. When we exclude the string having length 0 from the Kleene closure, we will get epsilon, or we can say positive closure. Next, From the string we can derive language. So a language is a set of strings over the given alphabet. As I have already discussed, we have learned English grammar in our childhood. From alphabets we learned word, and from word we learned to make sentences. In the same way, from alphabet to string, and then string to language. Language is what? It is a set of strings over a given alphabet. Here I have given you few examples of the language. Like if I am taking the alphabet 0 comma 1, so the language L is the collection of all the strings over the given alphabet 0 comma 1. Like it includes epsilon also. Epsilon is a string having length 0, then any possible combinations of 0 and 1, and this is what we called as a language. In the second example also I have given you the collection of string which is called as language. The first example represent all string consisting of zeros followed by ones, but in the second example all the string which contains equal number of zeros and equal number of ones. Now, the next slide is the membership problem. Membership problem represent given a string W means string means over the alphabet, given over the alphabet summation symbol sigma. Given a string W over the summation symbol sigma and a language L, decide whether the string W belongs to L or not. Here I have given you an example. There is a string 10011, so it belongs to the language of string with equal number of zeros and 1 or not. So that means it is the member, this string is the member of the language of string with equal number of zeros and ones. As we can see that there are 3 ones and 3 zeros in the given string, so that means this string belongs to that language containing equal number of zeros and 1. Now, we can categorize automata in two ways, like finite automata in two ways. First is your NFA and the second is your DFA. Finite automata can be broadly categorized into two parts, acceptor and transducer. Further, we can divide acceptor in DFA and NFA and transducer as Murray and Mealy. So here in the slide, I have given you the few applications of finite automata. That means first application is software for designing and checking the behavior of digital circuit. Second application of finite automata is lexical analyzer of a typical compiler. Third application is software for scanning large bodies of text. And the fourth finite automata application is software for verifying system of all types that have a finite number of states. So this is the one of the example of finite automata if we are taking one switch on and off. So what this switch represent, this is the example of finite automata. See, if we give any input to the machine, it give exact output corresponding to that input. That means what? If we switch on the machine, then our fan can work, and if I am going to off the machine, then our fan can off. So this is what, if we give any input to the machine, it gives you the exact output of corresponding to that input. So in this course further we will discuss various application of finite automata, acceptor, transducer, and further acceptor can be divided into DFA, NFA, and transducer as Murray and Mealy machine. So this is all about our introduction to automata theory. Thank you so much.